What's up, ladies and gentlemen? It is Mr. Pearson coming to you guys with another physical science update. It is Monday, December 7th, and we are moving on in Investigation 5. So we have made our way through most of the stuff in Unit 1. We're here in Investigation 5. Okay, as you can see on my screen, there are 4 activities. We did 1 and 2 last week. We are going to be doing 3 and 4 this week. Early next week, we'll have some review type materials because we're actually getting ready for a bit of a larger assessment. Instead of a quiz for Investigation 5, there is going to be sort of a cumulative type assessment that goes over everything from Unit 1. Okay, so we'll spend some time next week bringing everything together from Investigations 1 through 5 and getting ready for that. But this week we got to finish up Acts 3 and 4. Today specifically, we're moving on to Act 5.3. Our big question: what causes neutral objects and charged objects to interact with each other? All right, there's 2 simulations. I'm going to jump over to the interactions page here. See our same essential question. Okay, there's a couple questions for you on this first page, but there's 2 big simulations that go along with Act 5.3. And as we have come across these assignments that you guys should be taking screenshots of, just remember that generally, like, you would be taking a screenshot of this whole simulation here, all right? And in this activity specifically, there are 4 parts where it asks you to take a screenshot right here on the Interactions website. So it should be pretty clear as to how exactly you should need to set it up. But to go over this first simulation, what happens if I've got a very simple atom right here in the center, and I have 2 plates like we've seen before, and we can change each plate to either have a highly negative charge, a highly positive charge, or somewhere in between. Okay, and we've seen this electron cloud before, and what we can see is that it is moving based on the charges of these plates. Okay, and if I combine 2 different types of charges or 2 of the same charges, we can see that we're going to have different reactions, different interactions. Okay, so again, 2 situations here. It's asking you to set up 2 different ways. Take a screenshot of each of them. Moving on to our second simulation. Again, there's 2 situations it asks you to set up. So hopefully that clears up what exactly you should be looking for. But again, we can change the balloon to be negatively charged just a little bit. So it can be very positive, very negative, or again, somewhere in between. Okay, I can also click to show the atoms on, this is supposed to be just a little section of the wall. Okay, and again, you can choose to show either this cloud like we've seen before. I think it's a little bit easier in this one to show the individual electrons because it's showing us very simple atoms in the wall here. And again, as you change the charge on the balloon, you should see a different interaction with the atoms in the wall. Again, 2 different scenarios it would like for you to capture right there. Okay, you're adding those to the Google Doc that is attached to this assignment here. The last thing, instead of a check for understanding today, I'm asking you guys to explain to me in that second simulation The balloon can change charges, but it still sticks to the wall. We've talked about neutral objects sticking to charged objects in the past. Why do we think this is the case? We've come a very long way from talking about how laundry sticks together when it comes out of the dryer. We've learned a lot about particles that make up all objects and the protons, neutrons, and electrons that make up these particles. Okay, so what do we know now that we did not know in September and October that's going to help us explain why clothes stick together when they come out of the dryer? Again, I know that question came up a long time ago, but we are finishing up Unit 1, and there's going to be more of a cumulative, all summarizing type of assignment coming up. So just want to try to pull that stuff out. I know it might be buried in pretty deep, but it's in there, and I am confident of that. So as always, shoot me questions on Schoology, and if not, I will talk to you guys later.